man. They're all about the action. Looks like he's going to put the judge. I don't know. So, one side.
Hello everybody, welcome back. We're here with another robot breakdown video. This time we have Tirade, our 1-pound Antweight robot. This one's a 360-degree rotary lifter, kind of like Breaker Box from BattleBots. That's kind of where we got the inspiration. But this robot is entirely powered by brushless motors. So on both the lifter and the drive, we took brushless outrunners and paired them with gearboxes. That's what gives it its fun little dance moves. But do be aware, if you're looking for design ideas, that this kind of conversion is pretty difficult to put together. It took us about a year to get this robot working and ready to compete, so just be aware of that if you're ever looking into brushless drive. However, it does offer some pretty sweet power to weight, as well as some pretty crazy speed. This robot's build pretty well mirrored its fighting style, which is to say that Tirade came into the world kicking and screaming, and it never really stopped. So this has been one of the more fun and one of the more challenging robots that we've built so far. Without further ado, let's take a look inside. First, we're gonna pull off this top panel here, get a look at some of the guts. One thing that's going to be apparent through this entire process is that this is one of the sketchier robots that we've ever built. You can see one example of that here is the EndBot's power switch, which has been taped to the top panel since I was too lazy to drill the holes to properly bolt it. The top panel itself is 0.03 inch thick Garolite. I just got a sheet from McMaster-Carr and cut these up by hand using a pair of shears. Do be careful with this stuff because it does put off some pretty nasty dust, so make sure you're not breathing that in if you're cutting it. It's pretty standard stuff for Antweights if you don't actually need top armor. The very few times it's ever been hit by anything, it hasn't held up spectacularly well, but I also haven't had to replace the sheets yet, so if you're going to use Garolite, don't get hit. But otherwise, it's a pretty decent top cover for just keeping stuff in. So like I said, EndBot's power switch turns the robot on. It's powered by this Nanotech 450 milliamp hour battery. This is, I think, on the medium-large size for Antweight batteries. It definitely needs the current output, though, for these brushless motors, since they have a lot of current draw. Pull that out. Now you'll notice some of the parts are missing, so I'm going to throw up a picture of what it looked like before the competition. But at its most recent event, I had to pull a lot of the parts out, most notably this one of the rear drive motors and the wheel that was attached to it. And the drive belts are also missing. Also in here we've got the Hobby King T6 receiver, as usual, since that's what I use for most of the bots that I build. And then a trio of 20 amp Spiders ETW speed controllers. Now I don't think you can get these anymore, but what I did was I just stuck all of these in here, flashed them with BL Heli with the settings allowing for reverse so that the motors could move in either direction. That was one of the more time-consuming parts of the build that required quite a bit of troubleshooting. There's a little bit of wire management here, just excessive tape helping these bullet connectors avoid getting pulled into the outrunners. Next up, I'm going to remove the plow. So this plow is attached to a 1/4 inch aluminum axle, a live axle, which is actually made from 2 aluminum standoffs which are threaded together. That allows me to thread a screw that helps retain the arms on either side, and that also just allows for it to be lighter since standoffs are partially hollow. I originally designed it for a steel axle, except it was too heavy. This robot ended up being quite a bit overweight over time and had to be shaved down quite a bit. I also embedded some nuts in these 3D printed Onyx arms, which allow me to retain them with something similar to a set screw, kind of a DIY set screw in here on either side. And then the plow itself is 0.01 inch thick 1095 Blue Temper spring steel, which is a really nice, hard, but also flexible, thin steel, which worked pretty well for the front plow as armor. As you can see, it got pretty beat up when it fought a drum spinner at the last event. So this is actually kind of stuck here in the arm. It's a pretty tight fit, so rather than try to pull that off, I'm just going to allow the two sides of the axle to unthread, and that'll come apart in the middle. You can't see where they meet because of this Arby's straw that I put around as a cover to help protect the electronics from getting rubbed on by the internal axle. And this whole thing just slides out. You can see the long set screw that I used just threaded into this standoff that allowed it to thread into the other side. And then this other standoff on the other side forms the other half of the lifter axle, which is powered by this SK3, I believe it's SK3 2122 1200, 2100 kV into a 43-to-1 22mm Servo City gearbox, and then that's geared 1-to-1 to the lifter, which goes into this Onyx gear. Now this Onyx gear it's a mixed bag of results because it hasn't exactly held up. The teeth do tend to strip. However, the nice thing is because of how flexible Onyx is, it still does actuate the lifter. And so in some situations, this actually acts like a clutch where the gears kind of skip. Like I said, this is one of the sketchier robots I've ever built. I'm not going to pretend that that's a good design, but it does work for what this robot is. Here you can see more of the wire management. I'm just going to pull this out of the way so that I can pull all the electronics out. And the motors are all connected to the ESCs with bullet connectors, and the electronics just fall out like that. So here we're left with just the motors and the frame. The drive motors are kind of hard to see, but they're in the back. One of them's missing on that side, but that's a smaller Emax RS1106 Outrunner. It's 6000 kV, and I run at 3S, so that's a pretty fast motor. But the Maxim gearhead that's in there is also a 67-to-1 gearhead. So here you can see the motor assembly with the Outrunner's bell removed. So here you can just see the stator and the base of the motor mounted onto this Maxim gearhead by a 3D printed Onyx shroud. Shout out to Jonathan LaPlane for innovating this idea. He had aluminum shrouds for his gear motors. I decided to try to make it a little lighter and cheaper to manufacture by 3D printing with Onyx from NBots. So the theoretical output at this shaft is something around 1000 RPM, which for the 1.25-inch foam wheels that I have is a pretty standard output. It's not ridiculously fast. It is pretty squirrely because of the BL Heli firmware and the ESCs. They're not very well optimized for low-end torque. But these motors, overall, they don't not work. Now for this Maxim gearhead, since I'm pumping such a high RPM into the input, I had to clean it out and replace all the oil with white lithium grease. That was so that I don't ignite the oil when I spin the motor up to full RPM. Now, does it ever reach full RPM? I'm not sure. I've never run it on a tack or anything, so I wouldn't know. But I do know that that motor gets up to a pretty insane speed. On with the disassembly. The frame consists of two printed Onyx inner rails. I originally had UHW rails, but they were too heavy, so I switched to Onyx. And they are attached to each other primarily by these two cut-up sections of aluminum tube that I formed to create the front and rear panels that also serve as structure. Now these are pretty heavy, but they also haven't been penetrated by any other robot yet, so they've definitely done their job of protecting the internals and keeping the robot together. It's 16th inch thick aluminum tube. Something I did a lot of in this design was to embed nuts in the Onyx rails. I also did that, you can see a little bit better with the arms. There's one nut, and then there's some more where the Plow mounts to the arms. The arms themselves have seen some failures with this, with layers splitting right around the points where those nuts are. So there's a bit of refinement that needs to happen with this design, but it was also pretty cheap to manufacture and it didn't not work. Now Onyx is kind of complicated. I didn't want to run with heat set inserts because especially here, the force of the screw into the shaft is directly opposing what would be the insert direction, so I wanted there to be material physically holding that. And onyx also is pretty slippery and doesn't hold inserts very well. I suppose another option would be to get large threaded like plastite or wood screws and try to thread into the onyx, but I also am kind of skeptical as to how that holds up. But future versions will experiment with different setups for this. The front wheels are free spinning. It's actually an entire printed hub on a dead axle, and then I have a bushing in the rail to hold the lifter axle. Here you can see the motors. Here's the outrunner attached to the Maxon. So I use the finger tag hubs. I use the 3/4 inch wide hubs with the 1/2 inch wide wheels, and then a printed pulley slipping around the hub to allow me to drive the front wheels with a belt. And then here you can see the RB straw. It's a little bit sticky from touching all the internal parts and the electrical tape. The gear is also onyx and also uses the same embedded nut set screw method. This has worked pretty well for this. The side armor is 1/8 inch thick UHMW just to protect the wheels and this gear train in here. And it's attached to the main frame just with these standoffs. Again, 1/4 inch diameter aluminum standoffs. So this front wheel, like I said, on an entire dead axle here, it's just an M3 bolt with some 3mm ID bearings inside just to allow it to freely spin. There's a little bit of wobble, but it doesn't really matter. I mean, it's a foam wheel anyway. The hub was based on the FingerTech hub design, and it even had the groove for the snap ring. That part on this side broke off. You can see part of it is missing, which is why there was no washer holding the wheel on. So it was really just the side armor holding that on for its last fight at the most recent event. If I unscrew this, now you can see the M3 screw going through. Over here you can see closer up the gear train here with the embedded nut for the set screw. And a close-up on the gear teeth. So yeah, that is the basic teardown on Tirade. I hope you enjoyed seeing what makes this robot tick and hearing a little bit about the build process. With the whole quarantine situation, I'm locked away in here with not that much to do, so hopefully I will be able to get some more videos made in the near future for you guys. Feel free to subscribe to the channel if you enjoy this kind of content, and as always, happy roboting.